basketball. Are you unwilling to admit defeat from last time?
What, Camille? Who lost the basketball game? It's you, not me.
Well, Kay, there are always winners and losers in a game. You don't have to care about the results. By the way, I think we should review our scores. Let's look at them. In 1 minute, your average score is 32. The median score is 32, while the mode score is also 32. In 1 minute, my average score is 32. The median score is 32, while the mode score is also 32. Kay, you really don't have to argue. Look at our scores. Our performance is clearly shown. Who did better? Of course it's me. Our scores plotted on a number line looks like this.
We have already discussed the central tendency.
So since we're discussing the measure of central tendency, will the mean, median, mode be different if there are changes in a set of data?
Sure, when there are changes in a set of data, it will bring about changes in the mean, median, and mode.
So if there are changes in a set of data, how would the new mean, median, mode be different from the original averages? Also, how do we effectively find out the values of the new mean, median, and mode?
No problem. Let's make some changes in a set of data and see whether we can come to a conclusion. So Camille, why don't we use our scores of basketball game for this investigation? This is the score of my 10 rounds and the mean, median, and mode. If I could improve my skills through practice and I could raise 5 points for each shooting, the new scores look like this. The new mean becomes 37 points, the median becomes 37 points, and the mode becomes 37 points. The new scores plotted on a number line like this. The shape of distribution of new scores on the number line is the same as the original scores, but only shifts to the right side by 5 units. It is because 5 points are added to each item. So Camille, can you see the relationship between the new mean, median, mode, and the original averages?
Upon the operation, we can deduce that for a set of data with mean, median, and mode, if a constant k is added to each datum, then a value of k will be added to the mean, median, and mode respectively.
Camille, what are the effects on these averages if we multiply a constant to each datum?
This time, let me multiply my score of 10 rounds by 2. That is, double the result of each score. The result is like this. Due to the changes of the scores, the new mean is 64 points, the new median is 64 points, and the new mode is also 64 points. The new scores plotted on a number line will look like this.
Camille, what relationships are there between the mean, median, mode, and the original averages? Can you note by multiplying 2 to each score?
Upon the operation, we can deduce that for a set of data with mean, median, and mode, if each datum is multiplied by a constant k, then the mean, median, and mode is multiplied by k respectively.
Camille, such changes of data do really occur in daily life, and there are some examples too.
That's right. Like in a football team, over time there will be an increase in the ages of staff and players, and that is a constant added to each datum. And the averages will also be increased by this constant.
Likewise, a team of staff with the same percentage increase in salaries, that is a constant multiplied to each datum. The new averages will also be multiplied by this constant.
Well, Kay, are there any other situations where changing the data will also lead to changes in the mean, median, and mode?
Of course, let's discuss it further. So Camille, if we deleted a datum from a set of data, what will be the effect on these three averages?
Well, the effects on the mean, median, and mode will depend on the position and nature of this datum.
To the effect on mean, firstly, the deleted datum is smaller than the mean. Using the previous example, in this set of data, the mean is 32. If 18 is deleted, 18 is smaller than the mean. There are only 9 terms left in this set of data. The new mean is 33.56 points. Median is 32 points. And the new mode is 32 points. The plotting of these 9 terms on a number line is like this. As the effect on mean, the second situation will be the deleted datum is greater than the mean. In this set of data, the mean is 32. If 50 is deleted, 50 is greater than the mean. There are only 9 terms left in this set of data. The new mean is 30 points. Median is 32 points. And the new mode is 32 points. The plotting of these 9 terms on a number line is like this. Here's the conclusion. A datum is deleted from a set of data. If this datum is smaller than the mean, then the new mean will increase. On the other hand, if this datum is greater than the mean, then this new mean will decrease.
So, okay, what about the median if a datum is deleted?
To the effect on median, the first situation is the datum is smaller than the median. In this set of data, the median is 32. If 24 is deleted, 24 is smaller than the median. There are only 9 terms left in this set of data. The new mean is 32.89 points. The new median is still 32 points. And the new mode is also still 32 points. Plotting these 9 terms on a number line is like this. To the effect on median, the second situation is the datum is greater than the median. In this set of data, the median is 32. If 44 is deleted, 44 is greater than the median. There are only 9 terms left in this set of data. The new mean is 30.67 points. The new median is still 32 points. And the new mode is also still 32 points. Plotting these 9 terms on a number line is like this.
So, okay, apparently there's no effect on the median if the data is deleted.
Camille, of course not. There's no effect on median in this situation. However, it does not apply to other situations. Let's use this data, for example, and investigate the effect on median when a datum is deleted.
Well, anyway, Kay, can you make a conclusion? What is the effect on the median if a datum is deleted?
Yes, the conclusion is, when a datum is deleted from a set of data, if this datum is smaller than the median, then the new median will increase or remain unchanged. On the other hand, if this datum is greater than the median, then the new median will decrease or remain unchanged.
I see. So if the deleted datum is not the mode, then the new mode will not be affected.
Smart girl.
Thank you. You will surely learn more by doing more, thinking more, and making more observations.
Camille, as you're so hardworking, can you share with us the effects on mean, median, and mode if an item is added to a set of data?
Suppose 10 is added to a data set. 10 is smaller than the mean. There are now 11 terms in the data set. The new mean becomes 30 points. The new median is 32 points. And the new mode is also 32 points. If 54 is added, 54 is greater than the mean. There are now 11 terms in a data set. Then the new mean is 34 points. the new median is 32 points, and the new mode is 32 points. The conclusion is, when an item is added to a set of data, if the added data is smaller than the mean, then the new mean will decrease. On the other hand, if the added data is greater than the mean, then the new mean will increase. As for the effects on the median, when an item is added to a data set, if the added data is smaller than the median, then the new median will decrease or remain unchanged. On the other hand, if the added data is greater than the median, then the new median will increase or remain unchanged. And if the added item is the mode, then the mode of the dataset will not be affected.
Camille, we have already discussed adding an item to a dataset. What about adding 0 to a set of data?
Well, okay, why don't we discuss the effects on central tendency if we add 0 to a dataset? Let's first discuss the example with all positive integers. 0 is smaller than the mean, and there are 11 terms in the dataset. The new mean becomes 29.09. The median is 32, and the mode is also 32. You can see that if 0 is added to a set of data with all positive values, the new mean will decrease, the new median will decrease or remain unchanged. Now, let's discuss the example with all negative integers. 0 is smaller than the mean. There are 11 terms in this dataset. The new mean becomes minus 29.09. The median is minus 32, and the mode is also minus 32. You can see that when 0 is added to a set of data with all negative values, the new mean will increase and the new median will increase or remain unchanged.
Camille, you have either used positive integers or negative integers examples for discussions. What is the effect on central tendency if a set of data includes positive integers, negative integers, and 0? And what is the effect on the mode in the above examples?
Okay, that is exactly what I need you to explore. If you use the right examples, list the correct expressions, then you can come to a reasonable conclusion. So, Kay, previously we have discussed the effects of changing data on various measures of central tendency. How about the effects of changing data on dispersion?
There may or may not be any effect.
Why are you being so weasel-worded?
I'm not weasel-worded. The occurrence of effect depends on particular situations. The effects can be different.
Well, can you tell me more?
Camille, following our previous discussion, let's discuss the effects on dispersion when a common constant is added to each term of a set of data. Let's use our scores of 10 rounds of basketball game. If 5 points are added to each round, the new score is like this. Although there are changes of scores, the new range, interquartile range, and standard deviation remain unchanged. The new scores plotted on a number line is like this. The spread of data remains the same. Shape of distribution of new scores on the number line is same as the original scores, but only shifts to the right side by 5 units. It is because 5 points are added to each item.
The conclusion is, if a constant k is added to each datum, the range, interquartile range, and standard deviation will remain unchanged. Now let us observe the effects on dispersion if each score is multiplied by 2. When each score of my shooting is multiplied by 2, here are the new scores. Due to the change of scores, the new range, interquartile range, and standard deviation are the double of the originals. New scores plotted on a number line like this. The conclusion is, If a constant k is multiplied to each datum, then k is also multiplied to the range, interquartile range, and standard deviation respectively.
If constant k is negative, what are the effects on range, interquartile range, and standard deviation?
Well, if k is negative, then the range, interquartile range, and standard deviation will each become minus k times the original values. But in practice, we seldom consider multiplying each datum by a negative constant.
Finally, let's discuss the effects on dispersion if an item is added or deleted in a set of data.
Well, okay, let's listen to your discussion. First off, it is about when an item is deleted.
Here are weights of 10 terms. If an item is deleted in this set of data, let's observe the effect on range. If the deleted item is not the largest datum or smallest datum, then the range will not be affected. Next, let's observe the effect on standard deviation. If the deleted item is further away from the mean, then the standard deviation will become smaller. On the other hand, if the deleted item is closer to the mean, then the standard deviation will become greater. For the interquartile range is not easy for conclusion. The observation and analysis depends on each particular situation. In general, if the deleted item from a set of data is further away from the mean, then the standard deviation will become smaller, whereas if the deleted item is closer to the mean, then the standard deviation will become greater.
This theory can be applied to some sports competitions, such as diving competitions and gymnastics. Each contestant is assessed by a team of judges, each giving a score to the contestant. However, the highest and lowest score will be excluded from calculating the final score. This will help eliminate bias by an individual judge who may give an unreasonably high or low score.
Smart! You can put theory into practice immediately.
That's right. Do more and think more. It will definitely help our understanding. So, Kay, why don't we talk about the effects on dispersion if an item is added to a set of data?
Let's use this 5 terms data set. If an item is added, first let's observe the effects on range. If the added item is not the largest datum or smallest datum, the range will not be affected. Next, let's observe the effects on standard deviation. If the added item is further away from the mean, the standard deviation will become greater. On the other hand, if the added item is closer to the mean, standard deviation will become smaller.
According to examples, adding an item to a dataset is just the reverse process of deleting an item from the dataset. Therefore, the effects on dispersion of the whole set of data is just the opposite.
Correct. In general, if an item added to a dataset is further away from the mean, then the standard deviation will become greater. Whereas, if the item added is closer to the mean, then the standard deviation will become smaller.
Okay, today we have discussed many effects on the central tendency and on the dispersion of changing data.
Yes, there are observations and conclusions we can draw.
Well, by doing and evaluating examples, deducing the general form, gaining understanding of mathematics is not difficult at all. Learning mathematics is fun.